this video, we are going to focus on perimeter and area of two-dimensional shapes. This will be an introductory video on this topic. First, let's investigate all the various shapes and the formula for each particular shape's area. We'll start off by considering the rectangle. We know opposite sides have the same lengths. So we have length and breadth. L for length, B for breadth. The area is simply taking the length and multiply it by the breadth. Next, we focus on the square. We know the square is simply a very specific kind of rectangle. It's a rectangle where now all the sides are the same. So all four sides have the same length. So we can replace therefore for our formula for a rectangle the breadth with a length. And length times length is length squared. The parallelogram, we simply take the base and multiply it with the height. It's important here that it has to be a perpendicular height. In other words, the height at a 90-degree angle with the base. Our rhombus, we know for our rhombus also we have four sides equal, but we don't have necessarily 90-degree corner angles, whereas for a rectangle you have 90-degree corner angles. So the area of a rhombus is similar than for the parallelogram, the base times the height, which we can also express as AC. When we look at diagonal AC, we multiply it by diagonal BD and multiply that answer by a half. So simply take the two diagonals of a rhombus, multiply the lengths by each other and multiply by a half. That is if the diagonal properties are given. On the other hand, if we have the length of the bases and we can determine a perpendicular height, then we can use the base times the height, because we know a rhombus is also just a very specific parallelogram. Then if we look at the kite, we use in fact the properties of the diagonals. So it's basically the same as the rhombus in that respect. We simply take the length of the diagonals, so it's AC times BD, and multiply that by a half. Our trapezium, we also have to work with the height, the perpendicular height at 90 degrees. And then we know the parallel sides are not necessarily the same length. They usually are not the same length. So what we do is we add the two parallel sides, A plus B, and kind of take an average. So we take A plus B, multiply by half to get the average, and then still multiply by the perpendicular height. So here it's just written in a different format, but it's easier for me to remember it as saying A plus B, multiply that by a half. So we can even put it in brackets. Brackets means multiply and then multiply it by the perpendicular height, because order of multiplication does not matter. It's the so-called commutative law. 5 times 3 is 15, 3 times 5 is also 15. triangle one you know very well since primary school even. So we take half the basis times the perpendicular height. So it's always the side that's met by the perpendicular height, which is the base. And the circle, you also know even from primary school, we have pi, which we also know we can approximate by 22 over 7 or 3,142. And we know we have an infinite number of decimals. So we take the radius, which is from the midpoint of the circle, and we square that radius and then multiply by pi, which is either 3,142 or 22 over 7 approximately. So now that we have revised the formulas for the areas, let's work through a few examples. So number 1A of exercise 14.1, we can see we have parallel lines or parallel sides, opposite sides are parallel, and it is given that we have a perpendicular height of 5 centimeter, therefore we have a base of 7 centimeter. This is a parallelogram, because we know parallelogram have two pairs of opposite sides that are parallel, and we know the formula for the area of a parallelogram is the base times the height. So our base is given as 7 centimeter. We multiply it by the height, which is given as 5 centimeter. So 7 times 5 is 35, and centimeter times centimeter is centimeter squared. So we have squared centimeter units, which makes sense because we are working in two-dimensional space. So therefore all areas should be square units. Number C. In this particular case, we are given a perpendicular height. We see we have one side that's 6 centimeter, another side that's 11 centimeters, so it's not the same length. This has to be a trapezium. So we know in fact these sides are parallel. So our formula for the area of a trapezium is we simply add the longest and the long and the short side for the parallel pairs and take the average of that. So we multiply a half by a half, the 6 centimeter and 11 centimeter that we added, and that answer we multiply by the height of 5 centimeter. So we just applied the formula. Area is half A plus B, where A is the shorter side of the parallel sides and B is the longer side, and the H, the height, is the perpendicular height. So if we simplify, 6 plus 11 centimeter results in 17 centimeter. We still have to multiply by the 5 centimeter. So 10 times 5 is 50, 7 times 5 is 55, so it's 85. So we have half of 85, which is 42 and a half square centimeter.